Hello students, welcome to today's chemistry class on the topic test for reducing sugars. Test for reducing sugars. What is a reducing sugar? A reducing sugar is a carbohydrate, a simple sugar, a carbohydrate which has a bond like this, a carbonyl group like carbon oxygen double bond containing the sigma bond and a pi bond. As a result of containing pi bond, the electrons are loosely held and the electrons can easily be donated to an oxidizing agent. That's an example, or that's an illustration of what a reducing agent or reducing sugar is. An example of a reducing sugar is glucose. How can we test for glucose? This is actually a qualitative analysis. So test for reducing sugars. We will be reporting the test the way we report practical or tests on qualitative analysis. The sample we're going to work with today is a sample of glucose. This is our sample D, as you can see, sample D. Glucose, like you've been taught in your SS3 chemistry, is a reducing sugar because it has an aldehyde group, carbon oxygen double bond and carbon hydrogen single bond. This is a carbonyl group containing pi electrons, pi bond. To test for reducing sugar, the first thing we do is to get a sample of a reducing sugar like this glucose I have here. Then with my spatula, I'll get a spatula full of it and drop in an empty beaker. Then I'll add about 5 cm cube of distilled water and stir. Remember, when we stir, we are trying to encourage dissolution. If that substance is actually soluble, if it will dissolve, we are trying to encourage the dissolution. While you stir, you also observe, is there any color change? Is there any visible color change? Will the solids still remain? From the observation I have here, no solid is remaining, no particle is remaining. The sample dissolves completely. Do you understand? You have to report this stage. Looking at the board, you have sample D here. When you add water to it, what's the report that we have here? D dissolves. What color of solution do we have here? It's colorless. So we write colorless solution. And what is going to be the inference? The inference is that D is a soluble substance. We move on. This is our test tube. We take about 2 cm cubed of this solution, about 2 cm cubed of the solution. Then to it we add Fehling solution. This is sample D in aqueous form. Then to it we add Fehling's solution. Then we heat. Fehling solution, I already have my Fehling solution here, which contains copper 2 ions in it. I'm going to add some Fehling solution to this. The instruction says heat. In the chemistry laboratory, what is the apparatus we use to heat a solution or a sample if we are told to heat? We use the Bunsen burner. But right in front of me here, I have an improvised Bunsen burner, which is this. So I'm going to light it up. Remember, before you put it on, you have to put on the light, the fire, so that the first gas that comes out ignites. Do not put on the gas, the Bunsen burner, before you put on the light, the fire. No, the fire has to come up first before you open up the knob of the Bunsen burner. This is our improvised Bunsen burner. And then this is our test tube that contains the reducing sugar, that's sample D, and the Fehling solution. We want to heat it. Am I going to hold it like this with my bare hand and then heat? No, that would be risky. I need my test tube holder. Do you see my test tube holder? Yes, the wooden test tube holder. I have to carefully hold this like this. The next thing, I have to get my goggle and then put it on while I heat this sample. While I'm heating the sample, I'm not going to position it to face the students, not to face myself. I'm going to make it to face where students are not positioned, or where no other person is positioned, whether student or lab attendant or the teacher. It has to face this way. That is a precaution while you are going to heat. You also make the precaution of holding the test tube or the boiling tube using the test tube holder. Do you understand? You have to maintain precaution when you're in the science lab. Then you heat. As you bring it close to the Bunsen burner, you have to shake gently while you heat. While you heat, you observe. You're observing. Would there be any color change? Would there be any precipitate that will come up in the solution? Those are the things you are looking out for. And you have to be very careful while you are heating. If in your laboratory there's a ceiling fan or a table fan around you, should you leave it on? Should you leave it put on, turning round and round and round? What do you think it will do to the fire, the Bunsen burner fire? Won't it disturb it? So that's a precaution. You have to put it off. You have to put off the fan, and then you watch. Watch closely. Are you seeing any color change? Do you observe any color change so far? Students, are you observing any color change? Myself, I'm observing some color change. I'm observing a color change. What color are you observing now? Is the blue color of Ferlin solution, which is due to copper 2 ion, is it still there? Is it still present? What color are you observing now? Okay, we can stop this far and then put up the Bunsen burner and observe. Can you observe the color, students? What color are you seeing now? Is it the same as the blue of the Ferlin solution that we added to it? No. So we are concluding that we have a red precipitate. Red precipitate. Do you understand? There's a red precipitate here. Okay, you have to drop this and then report. Report what you have observed on the board. When we added Ferlin solution to the sample of suspected reducing agent and then we heated, we observed red precipitate. What does that tell us? That is a positive test for reducing sugars. So we have to infer reducing sugar present. Do you understand? Why do we have this observation here? Why do we have this red precipitate? Remember, Ferlin solution contains copper 2 ions, which are blue in color. And you saw that when we added the Ferlin solution to the sample. And reducing sugars, as I explained before, they contain aldehyde group. Carbonyl carbon is here, a sigma bond and a pi bond. This pi bond, remember pi bond is a bond formed when there is side-by-side overlap, sideways overlap of atomic orbitals. That's when pi bond is formed. While sigma bond is formed when there is head-to-head overlap of atomic orbitals. Do you understand? Now, the presence of pi bond, pi electrons, the electrons are loosely held. They can easily be given out to an oxidizing agent. So the reducing sugar, the reducing agent that we are working with today has pi electrons, and it can easily give out the electrons to copper 2 ion, which is blue in color. When that happens, the copper 2 ion is reduced to copper 1 ion. Do you understand? And the copper 1 ion has red color. That is the color you're observing as while we heated the reagents. Do you understand the mixture? That's the red color you're observing here. So take note that when reducing agents react with failing solution, red precipitate is observed as a result of the reduction of copper 2 ions to copper 1 ion. Do you have any question? If you have any question, feel free to drop the question on the comment area so that subsequently we can look at those questions. Thank you, students. See you in the next class.